Alright, welcome again. So in this video we're going to review a very popular algorithm in sorting. It's called the selection sort. The selection sort. Now this algorithm is pretty straightforward. If you have an array that has elements, it always starts an index that points to the very first element, and then starting from that element, it searches the rest of the array looking for the minimum. It looks for the minimum number, okay? So if we have, for example, 5, 3, 7, -1, -3, 4, it'll pick -3 because that's the minimum number. Let's say -3 is here, okay? And then it swaps these two numbers, okay? After it finds the minimum number, it put -3 here, and it puts 5 here. So we know that the minimum number is at the top left, at the leftmost of the array, okay? And then we move to the next number, and we search for the minimum inside the array to the right, okay? The rest of the array. After we find the minimum, we swap it with the number inside the second cell here, and so on until we reach the very end of the array. After following this approach, we would have a sorted array, okay? Now, let's try to write an algorithm that would implement this idea. So the index that is going to start here, I'm going to label that as target. So the target will start from the beginning of the array up to the very last element of the array, -1. So for target starts at 0 up to the very last element, -1. So that's to n -1. Every time we're going to look for the minimum in the array that starts at target +1 up to n -1, okay, or up to n. So let's do that. So let's look for the minimum. So first of all, we're gonna initialize the minimum equals, let's call that the minimum index to be more significant. So the minimum index takes target, that's as an initialization, and then we're gonna loop the array. So for I starts at the target +1, so we're gonna start searching starting from the target +1 up to n. For every cell, we're gonna see whether that cell is less than t of min index or not. Let's consider this to be called t. So if t of min index is bigger than t of I, it means that t of I is less than the minimum number so far. So we're going to update the minimum index. So min index is going to take I, and that's it. Now we found the minimum number. Okay, we know the index of the minimum number. Now we need to swap that minimum number with the number at index target. Okay, so let's do the swapping thing. So we said that the swapping would be these 3 instructions. So the first instruction is, let's make some room here. So the first instruction would be to create a temporary variable which takes t of target. And then the second instruction would be that t of target, once we have a backup copy of t of target, we're going to put inside t of target t of min index. And then finally, once we've copied t of min index inside t of target, we're going to copy inside t of min index the temp. Okay, so t of min index takes the temporary variable. And now we completed the entire swapping. So yeah, and we close the for loop. And basically that's it. This is the algorithm that you have to follow in order to implement the selection source. So let's try to write this with a real code, like with C, and see whether it works or not. Okay? So let's make this a little bigger. And the function is of type void. It'll be called selection sort. It takes an array, so that's R. And it takes the size of the array, that's n. And basically we're going to have to follow the algorithm. So we said that the first thing the algorithm does is that it declares target, and target starts at 0 up to n minus 1. And then we said that we're going to declare a variable called min index, which is the index of the minimum element inside the array R. Takes target. And then we declare I, and then I starts from target plus 1 up to n. And every time we're going to compare t of min, it's called r here, r of min index. If r of min index is bigger than r of I, we said that it means that we found a number that is the new minimum, that is less than the minimum so far. So min index takes I. And then finally we're going to swap the number at index target with the number at index min index. So TMP takes R of target, and then R of target takes R of min index, and then R of min index takes TMP. And that should sort the array. Now let's try a sample array. So R with, let's make them 5 elements. So these are 5 random elements. So let's sort the array. So that's selection sort. The size is 5. And let's print the array. So we have I variable, that's the counter, and then we loop from I starts at 0 up to 5, and then we print every element. So print f an integer, and then a tab to separate the integers so that we can differentiate them from each other, and then R of I. Now let's test that. Well, here it says I was undeclared, so we call this target, not I. I was not incrementing targets. So that's an infinite loop. But now, as you can see, it printed the numbers sorted correctly. So 23, 54, and so on, the numbers got sorted correctly. And basically that's it. That's how to write and implement the selection sort algorithm. All right, now let's get back to, let's take a look at the complexity of this algorithm. Now, as you can see, this algorithm has a for loop that starts from target up to n, and target, at the worst case, starts from 0, okay? So here we have that's constant operation. So these are constants, and this constant is being repeated n times, so that's order n. And that order n times, here we have some constants, and here we have some constants. So if we have these complexities happening one after the other, then the overall complexity here is the maximum between all of them, okay? So that's the maximum between order 1 and order n and order 1, which is order n, okay? So we know that the complexity of all of this is order n. And we know that this whole thing is being repeated n times because target starts at 0 up to n, okay? So an order n thing being repeated n times, that's order n squared. So the overall complexity of all of this would be order n. And that's, of course, a constant, so it remains order n. So the complexity of our algorithm is order n squared, sorry. That's order n squared, okay? So basically, that's the algorithm. And that's its complexity. All right, thank you for watching, and see you in the next video.